Hi everyone, myself Dr. P. Ashok Babu, working as Professor and Head, EC Department. So in this video, I am going to discuss about some more problems on wave propagation. So the first one is a plane wave traveling in a medium of say epsilon r equal to 1, mu r equal to 1 has an electric field intensity of 100 into root pi volts per meter. So determine the energy density in the magnetic field and also the total energy density. So to find out the energy density, we have the formula energy density W is equal to epsilon into E square. Epsilon is nothing but epsilon naught into epsilon r. Therefore, energy density is equal to, we have epsilon naught into epsilon r into E square. Epsilon r is given as 1. Therefore, energy density is equal to, directly you can substitute epsilon naught into E square. But E is given as 100 into pi. 100 into pi. Therefore, the energy density is, we can substitute that directly. That is 8.854 into 8.854 into 10 power minus 12. 8.854 into 10 power minus 12 into epsilon r value is 1. And energy electric intensity square, electric field intensity square, that is 100 square into pi. Therefore, if you simplify the expression, we have 139 into 10 power minus 9 or 139 nanojoules per meter cube. Then, so it is electric field, the energy density by electric field. Then we need to find out the energy density by the magnetic field. So, as the electric energy density is equal to the magnetic field for a plane wave, for a plane traveling wave. Therefore, the magnetic energy density WH equal to, we have again same as the electric energy density, which is 139 nanojoules per meter cube. Therefore, the total energy density is equal to W is equal to, so here WH plus WE. So, it is 139 plus 139 nanojoules. So, total it is 278 nanojoules per meter cube. 278 nanojoules per meter cube. Next, the conductivity of a sea water is sigma equal to 5 moles per meter and epsilon r equal to 80. And what is the distance an AM wave can be transmitted at 25 kilohertz and 25 megahertz when the range corresponds to 90% of attenuation. Then we need to find out the distance of NEM wave. So we need to find out the distance of NEM wave. So we know that the attenuation constant is there. So the attenuation constant is given as, so it is attenuation constant is correspond to 90% of attenuation. Therefore, the remaining 10% is equal to e power minus alpha x. Therefore, e power minus alpha x equal to 0.1. 10% is 0.1. Then if you apply logarithm on both sides, so logarithm of e power minus alpha x equal to logarithm of 0.1. Then here logarithm of e power minus alpha x is equal to logarithm of 0.1. So it is minus alpha x into log e base e, and which is logarithm of 0.1. Therefore, log e base e equal to 1. Therefore, minus alpha x equal to, so logarithm of 0.1 is nothing but minus 2.3. So minus minus cancel each other. Therefore, x equal to 2.3 by alpha. X equal to 2.3 by alpha. Now we need to find out the alpha value. Then alpha is equal to, alpha is nothing but attenuation constant. We have the formula for attenuation constant alpha equal to omega into root of mu epsilon by 2 into 1 plus sigma square by omega square epsilon square minus 1. So from this expression, we need to find out the alpha value. So here, the given one is a conductor, or if sigma square by omega square, sigma by omega epsilon is dissipation factor. So because it is a high value for a good conductor, so therefore sigma by omega epsilon is very greater than 1. If sigma by omega epsilon is very greater than 1, then we can ignore this one. Therefore, we have alpha is equal to omega into root of mu epsilon by 2 into root of sigma square by omega square epsilon square, then minus 1. Therefore, alpha is equal to omega into root of mu epsilon by 2 into sigma by omega epsilon minus 1. Again, sigma by omega epsilon is very, very greater than 1. Then we can ignore this one. Therefore, we can write the expression for alpha. Alpha is equal to root of mu epsilon by 2 into sigma by omega epsilon. Epsilon, epsilon cancel each other. Therefore, we can write alpha is equal to root of mu sigma by 2 omega. Mu sigma by 2 omega. Where omega is nothing but again 2 pi f. Therefore, alpha equal to we can write root of mu is mu into sigma by 2 into 2 pi f. 2 pi f. Therefore, if you substitute the frequency f equal to 25 kilohertz, where mu is equal to mu naught, and epsilon equal to epsilon r naught. No need to substitute that epsilon r. Sigma is given as conductivity is given as 5. Sigma is 5. Therefore, if you substitute all these values in this expression, therefore alpha equal to mu is 4 pi into 10 power minus 7 into 5 by 2 into 2 pi into the frequency f is 25 kilohertz. 25 into 10 power 3. 10 power 3. So 2 pi cancel each other. 2 cancel each other. Therefore 5 into 1 by 5 times. Therefore it is root 10 power minus 4 by 5. So out of root it is 10 power minus 2 into 1 by root 5. So if you simplify the expression, we have alpha is equal to 7.702. Alpha equal to 0.702. Similarly, if you substitute frequency f equal to 25 megahertz, then we have alpha equal to 21.96. Then we need to find out the distance when the frequency f equal to 25 kilohertz and when the frequency f equal to 25 megahertz. Therefore, we need to substitute in the problem. We have alpha x equal to distance alpha equal to 2.3 by alpha. For x equal to 2.3 by alpha. Substitute x equal to 7.702 for the frequency 25 kilohertz. Then we have x equal to 3.27 meters. Then if you substitute alpha equal to 21.96, then the distance is 0.104 meters. Or in this way, we can find out the distance at different frequencies. Next, a plane wave with a frequency of 2 megahertz is incident upon a copper conductor normally. Then the wave has an electric field amplitude of 2 millivolts per meter. Then copper has epsilon r equal to 1, mu r equal to 1, and sigma equal to 5.8 into it is 10 power 7 moles per meter. Then find the average power density absorbed by the copper. Then we need to find out the average power. So to find out the average power, so here first I am finding the intrinsic impedance. Therefore, intrinsic impedance eta is equal to root of mu epsilon by root of mu omega by sigma. We have the formula intrinsic impedance eta equal to root of mu omega by sigma, where mu is nothing but mu is equal to mu naught into mu r is equal to 1. Therefore, mu equal to mu naught. Therefore, 4 pi into 10 power minus 7 into omega is nothing but 2 pi f. 2 pi into the frequency is 2 into 10 power 6 by, and here we have sigma is the conductivity sigma equal to 5.8 into 10 power 7 or 58 into 10 power 6. So if you simplify all this, 10 power 6 and 10 power 6 cancel each other. Then after simplification, we have 5.235 into 10 power minus 4. 5.235 into 10 power minus 4. Then we need to find out the average power. So the average power equal to, we have the formula half into E square by eta. Half into E square by eta. The electric field intensity E is given as, it is 2 millivolts per meter. Therefore 2 into 10 power minus 3 whole square. It is half into 2 into 10 power minus 3 whole square by, it is 5.235 into 10 power minus 4. So if you simplify the expression, it is 2 into 10 power minus 6 by 5.235 into 10 power minus 4. So simplify, after simplification, we have the power 3.82 milliwatts per meter square. Next problem. So a perpendicularly polarized wave is incident at an angle theta I is equal to 150. Incident angle theta I is equal to 150. So it is propagating from media 1 to media 2. Then media 1 is defined by epsilon R1 equal to 8.5, mu R1 equal to 1, sigma 1 equal to 0. And medium 2 is free space. So one is having the conductivity 0 and other one is known as a free space. If EI equal to 1 millivolts per meter, then determine ER, HI, HR, where ER is a reflected electric field intensity, incident magnetic field, reflected magnetic field. So here we need to find out the EI is given, we need to find out ER, HI and HR. So to find out that, first we will find out the intrinsic impedance for the two medias. So the intrinsic impedance of a media 1 is eta 1 equal to root of mu 1 by epsilon 1. Mu 1 is nothing but mu naught into mu r. Therefore, mu naught into mu r1 by epsilon naught into epsilon 1 r1. Therefore, root of mu naught by epsilon naught is nothing but characteristic impedance or intrinsic impedance. It is 377 into mu r1 is 1 and epsilon r1 is 8.5. Therefore, 377 into root of 1 by 8.5. And if you simplify the expression, we have eta 1 is equal to 129 ohms. So it is for media 1. So second media is nothing but free space. So if the media is free space, then intrinsic impedance is nothing but the characteristic impedance. Therefore, eta 2 equal to 377 ohms. By using the Snell's law, we have the formula sin theta I by sin theta t is equal to root of epsilon 2 by epsilon 1, which is equal to root of epsilon 2 is nothing but it is a free space. Therefore, epsilon r equal to in free space, epsilon r equal to 1. Therefore, root of epsilon naught by, for media 1, epsilon naught into epsilon r is 8.5. For epsilon naught cancel each other here. We have sin theta I by sin theta t is equal to root of 1 by 8.5. 1 by 8.5. And here we need to estimate the theta t value. Sin theta I value is given. So, sin theta I is 150 degrees. Sin theta is given as 150 degrees. Therefore, so here we can find out the sin theta I. Therefore, sin 150 degrees by sin theta t is equal to 1 by root of 8.5, or sin theta t is equal to sin 150 degrees by 1 by root 8.5. So here if you simplify the expression, theta t equal to 49 degrees. Now we need to find out the ER value, HI value, HR value. So here we have the ratio, the reflection coefficient of for a electric field is given by ER by EI. So ER by EI is equal to, we have the ratio eta 1 cos theta I minus eta 2 cos theta I by eta 1 cos theta I plus eta 2 cos theta I. So which is equal to 0.490, which is equal to 0.49 degrees, 0.490, which is nothing but the 0.490. If you substitute theta I value and in the same theta I value and eta 1, eta 2 values, where eta 1 is nothing but eta 1 is, so here eta 1 is 129 and eta 2 equal to 377. Therefore, 129 into cos theta I. Cos theta I is 150. It is cos 150 minus 377 into cos 150 by 129 into cos 150 plus 377 into cos 150. So here if you simplify this expression, we have 0.490. Therefore, ER equal to, we can write EI into ER, EI into 0.490. Therefore, 0.490 into 1 into 10 power minus 3. So, EI is given as EI equal to, we have 1 millivolts per meter. Therefore, 1 into 10 power minus 3. Therefore, it is ER is 0.490 millivolts per meter. Now, we need to find out the HI and HR. So, here we have the formula intrinsic impedance eta 1 equal to EI by HI. So, HI is equal to, we can write EI by eta 1. Therefore, EI is 1 into 10 power minus 3 by 129 and HI is equal to 7.75 microamps per meter. Similarly, we can find out the HR value. We know that ER by HR equal to again eta 1. HR equal to, we can write ER by eta 1. So, here ER is nothing but ER equal to 0.490 millivolts. 0.490 millivolts by 129. So if you simplify the expression, we have HR equal to 3.7987 microamps per meter. So in this way you can find out the electric field intensity of a incident wave, reflected wave, both and similarly for magnetic field also. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.